Morning, everybody. The door to Roberts North 12 was locked for some reason this morning, and so it took me a minute to get that open, and so we're starting a few minutes late. Today, quick discussion of grades and what's due or what things you should do to review your grades, and then finishing up what's needed for the last assignment for the non-graduating students. New issue posted in the GitHub repo about grades, and the first part of that is that your finals have been graded. This is what the grade distribution looks like. It's about what I expected, actually a little bit higher than it was last time I taught this course. So the highest grade, 116 out of 120, the median grade, about a 70%. The answer key is posted. You can go visit it, and it has all the answers to the true and false questions. There's no explanation to those, so if you want an explanation, I'd be happy to provide one. And then on the free response questions, it has a full credit solution to all of the problems, and the key has some annotations about common mistakes that lots of people miss points for. There's a lot of different things that people did, though, that maybe don't necessarily fall into exactly one of the categories of mistakes right here, and so your points off might not exactly match one of these. If you would like to have more details about why you missed points on a particular problem, then I'd be happy to look at that with you one-on-one. But the common mistakes should provide a pretty good guide, I think, about why your points are the way they are. Again, you can find in Sakai the total, your overall grade for the final, and in the notes for the final section, there is a list of where you missed points. I definitely recommend that you double check that I didn't make any grading mistakes in your finals, especially, so I was pretty careful, I think, in the free response part, but in the totaling up your points, or there's a good chance that I made some arithmetic mistakes there. And so if I did make any mistakes, I'd be happy to correct those for you. Any questions about that, about the final grade? Okay. Then all of your other grades fully up to date in Sakai, and in particular, the caveat tasks also entered into Sakai at this point. And the way I've done that is, if you've completed the task, then I put a 1 in the corresponding column. If you have not completed the task, then I put a 0 in the column. And the way that I will enter your grade into the portal is that if you have a 1 in both of those columns, then your grade in the portal will match whatever your grade is in Sakai. But again, if you have not completed one of those tasks, then each one of those tasks that are incomplete results in a full letter grade docking of your score. So if you're missing one of those tasks and you have an A- in the class in Sakai, then I would be entering a B- in the portal. So this is particularly important for graduating students because several of you have not completed the caveat tasks yet, and at this point you're already past the deadline for when they should be submitted. I'll give you a grace period until Thursday at midnight to complete these tasks, but I can't give you any longer than that because your grades are due this Friday, and so I have to enter them Friday morning. And if you haven't completed the task by then I'm going to have to give you that grade penalty. So please, especially the graduating students, make sure that you complete those tasks. The non-graduating students, you also need to complete those tasks, but you have a full another week to complete them. Also, the search engine assignment, I had extended the deadline originally until this Friday, but I'll go ahead and extend the deadline again until a week from today, Wednesday at midnight, so that everything remaining in this class will be due on Wednesday at midnight. And hopefully that maybe eases some of your deadline pressure burdens on things. But again, this is pretty much a hard deadline because have to get grades in. Any questions on admin stuff, grades, due dates? Okay. Then today, the main part of today is I have posted this final assignment, this wardial assignment. You can find it on the week 15 folder, then the link right here. And we'll just go over what to do in this assignment. I think it, compared to the other assignments, should be relatively easy. And we will also, today, basically talk about how to implement what you need to do for this assignment. As a reminder, we've been talking about this last assignments related to coroutines, asynchronous programming in Python, making our I/O operations faster by letting them go in parallel concurrently at the same time. And the main library that we're working with is this AIO, A for asynchronous, IO HTTP library. In Python, the convention is that any of these libraries that make use of async always start with AIO for asynchronous IO. And this one is for HTTP requests, web requests, so it's AIO HTTP. I didn't click this link, show us this link last time, but it just has a bunch of example projects of cool things you can do with AIO HTTP. And I just wanted to highlight that all of these example projects, they use all of the sort of material that we've talked about in the class up to this point. So like this polls or blog example specifically use both Postgres and this AIO HTTP library. And if you click on these examples and see their instructions for actually getting it running, you'll see that it also uses Docker to get things running. Some of the other ones, they don't necessarily use Postgres, they use Mongo or something else to store things in, but once you bring it up with Postgres, it'll all still just work. So all the knowledge should transfer to running any of these example projects. And so here's the wardial assignment. There's 2 tasks grading-wise for this assignment. The goal is just to complete the test cases so that both of these red badges turn green, and if you do that, you'll get full credit on the assignment. The main purpose of this assignment, again, learning how to use the async functions in Python. But then this sort of side purpose is we're going to be sort of crawling the web, and so an increased understanding of internet architectures and how they work. Some background on this assignment. There's a lab from CS40, the intro programming course I teach here at CMC, that does something called wardialing. And my recommendation is that you go through this lab and just to get a background on what you'll be doing in this assignment. I think a couple of you have taken CS40 with me, but this lab was added after you took the CS40. And so I would still recommend going through this even if you took CS40 with me. But there's nothing to turn in for the lab. It's just to give you some background on the assignment. And what that lab ends up doing is you scan all the computers on the North Korean internet for web servers, and it takes about an hour to run if you run the code that you get from that lab. The reason it takes so long, there's only 1,000 computers that you're scanning, but it takes a long time because the I/O requests do not happen concurrently. And so in this assignment, everything's going to happen concurrently. And so after you've implemented all the requirements of this wardial.py, you'd be able to run a command like this. This set of IP addresses right here happens to correspond to the North Korean internet, all of the IP addresses in North Korea. And it now takes 30 seconds instead of an hour to scan all of those IP addresses because you're doing them all concurrently. Here's another example of scanning all the IP addresses that belong to the Claremont colleges, and it takes 20 minutes or so to do. It would take, using the previous code, a couple of days to do it. So it's a big speed up doing stuff concurrently. There's more fancy things that you can do to speed this up even further, but that requires detailed knowledge of operating systems and network stacks that we're not going to get into this class. But this sort of state-of-the-art of scanning can scan every internet address, all 4 billion of them, in a little bit less than an hour. So there's still a lot more room for speed up on things than what we have here, but this is still pretty good. So the tasks, 2 tasks. Again, first, sort of maybe task 0 is update the README file so that the test case badges point to your repo instead of my repo. But then in this task 1 right here, the first task is to make the doc tests pass, complete, get a correct solution. But after you do that, you will, it'll still be running very slow because it's not using async functions correctly in task 1. And so task 2 is there's a second fix me that will make those async functions run quickly. And you do both of those 2 things, and the assignment will pass the test cases. Right here, I'm in my the week 15 folder. Go into the wardial on my solution. Let's check out the master branch real quick and open up the wardial.py. So this is the branch that that you're given. This is exactly what's on GitHub right now. And at the top of this file, there's a handful of non-async functions, ordinary functions, just for working with IP addresses. You don't need to see the details of these functions. You don't need to look inside of them. But ultimately, this netmask to IPs function is going to, basically what it does is it gives us a list of IP addresses from one of these net blocks, and then those will be the IP addresses that that'll be scanned. So the way that fits into the assignment is that when you're running the code, something like this first parameter right here just gets passed into that net block function in order to list out the IP addresses that will eventually get scanned. Again, nothing that you need to modify in these functions, but it will be important that this function here returns, or this function here is a generator function and not an ordinary function in Python. We know that it's a generator function because, if we look at it, well, so here it has an ordinary return statement. It's returning enumerate IPs. Let's go ahead and find the enumerate IPs definition. And inside enumerate IPs, we see the yield right here. So this yield means that it's a generator. And so netmask to IP is also a generator. This is going to be important because the way that you'll be having to work with the results of this function will be slightly different because of the fact that it's a generator. Then there's 2 async functions being defined. So again, async def means that it could possibly run concurrently. And this function right here is server at host is totally defined for you. There's also an analogous function to this in that lab that is a non-async function, but they do exactly the same thing. This just does it asynchronously. Again, you don't have to modify anything about this function right here. I'm providing that for you. This wardial_async function, this function is going to call the isServerAtHost function repeatedly, trying to check, given a list of IPs, a list of hosts, is there a server at that IP address? Most of this function is something that I have implemented for you, except for right here. This turns out to be, and we'll talk in detail about this here in a second, this turns out to be not a correct implementation right here. It gives us the correct results, but the runtime is incorrect because it is it's too slow. None of these operations, none of these calls to is server at host will be happening concurrently. And so we'll be still in that runtime of like an hour instead of 30 seconds. And then down here we have a non-asynchronous function wardial, which does it's like the main driver of this file. And this function is what links the asynchronous code to the synchronous code. In particular, it's supposed to call this wardial underscore async function, make sure all that asynchronous stuff goes away, make sure this async right here goes away, back into synchronous code, and get the results. And so this is not implemented and something that you'll have to implement. After that, there's just this boilerplate down here of actually calling the function, have some arguments right here, and then down here calling the wardial main driver function with the results from the net mask to IPs of whatever the person using the program typed in. Right here's the net mask. So I'll go over in a little bit more detail here in a second on like what to actually do step by step for those fix me tasks. But before doing that, are there any questions about the high level idea of high level structure of this code or this assignment? Okay. Then, so this first fix me task, I think this one should be hopefully relatively simple. The main thing to notice is that in this wardial function up here, because there's no async in front of it, we can just call this function directly, and everything works. In this wardial underscore async function though, because this one is async, it can't just be called directly. And you can look at the test cases right here to see how exactly you're supposed to call it. That again, anytime you're using one of these async functions, you need to define an event loop first. And turns out there's many ways to do that, but this is sort of a standard one. It's just saying loop equals Async Io, this built-in library for asynchronous functions, creating the event loop right here. And then you can call your async function by passing it to the loop run until complete. And so the wardial function itself is basically just going to look like some lines like this of create the event loop, call the async function inside the run until complete in the event loop, and then at the end close the event loop. So it shouldn't be too bad getting that to work. I think the more difficult part of the assignment is getting the wardial async code to actually be asynchronous. That's just defining your function. The main takeaway from this is that just defining your function with async like this is not enough to make the code actually be asynchronous. This just makes it possible for the code to be asynchronous. And so down here, this 4 lines of code will have to be changed to a different set of code. My solution happens to be just 2 lines that is going to allow the code to actually be asynchronous. And in order to talk about that, how to do that, I have 2 files in the folder, this 08 gather.py and 09 gather2.py that we will go over. And I'll do some transforms to code down here that'll end up being the same exact transformations that you should do to this code up here to go from the sequential to the concurrent version. And so there's a little bit of work to do in terms of just translating from like one application domain to another, but it should hopefully be a relatively straightforward set of steps. So I'll go over that, these two files here in a second, but before I do that, any questions about anything else related to the wardial file up here? Okay. Then, so down here in these two files, and again, these two Python files, you can find them in the week 15 folder. All of the, let's refresh that. All the files are contained up here. We went over the first 7 of them last class. Again, those just provided sort of more background information on the history of async in Python and some of the like plumbing under the hood. These last 2 files that we'll talk about today are more the practical, like actually using it and like figuring out these error messages. How do you resolve them? What do they actually mean? So more practical things. And in these 2 files, both of these 2 files are intended to do the exact same thing. They both have 2 functions, a worker function and a main function. The worker function prints hello world, waiting 1 second between each hello and each world. So again, this is simulating like our I/O of connecting to a web server, reading from the hard drive, any sort of I/O operation right here. And then it's just printing out these messages and doing a simple computation on the input number right here, multiplying it by 2. We'll return that list and print it out. And if we run that, I'll time the runtime of it. CD dot dot back into the week 15 time Python 3 or 08 gather.py. And you can see that it takes, so runs, printing out the I after the worker. The I after the worker is the parameter passed into the worker function, and that comes from this range right here. So it goes from 0 up to 9, and prints hello each time, waits a second, then prints world. And then at the end, we get the numbers 0 through 9 times 2. So 0 to 18. And it takes 10 seconds to do because there's 10 calls to these time.sleep, and they're all happening synchronously. This 09 gather2.py, similar code structure to the 08, except we now have a bunch of async functions. So we have the possibility of doing things asynchronously. And if we go ahead and call this one, 09 gather2, we can see that the things are in fact happening asynchronously. All these calls to hello up here all happened at essentially the same time. And then it waited a second, and then it did all these calls to world. You'll notice that these calls to hello are sort of in an arbitrary order. We'd say they're in a non-deterministic order. There's no way to predict what the order to these worker calls are going to be. That's going to be determined by the event loop, whatever it happens to decide. But they're all happening concurrently, and then at the end, we get the results back, and those results are still in order. So in order to talk about what's going on in here and all the different possible gotchas, we're going to just step-by-step convert this sequential program into a concurrent program and see a bunch of error messages along the way. And this sort of step-by-step process is exactly the same step-by-step process that you'll do on that task 2 on the wardial assignment. Any questions? Everyone's just feeling dead from the end of the semester. Lots of exams, projects, lots of everything.
Professor, I think I have a question.
Good.
Can we do this without using the Lambda server?
Question is, can you do this assignment without the Lambda server? And the answer is yes. Actually, so on the Lambda server, Python 3 -- version, we have a slightly older version of Python installed, Python 3.6. If you recall from our sort of like history of async up to Python 3.5, the syntax of asynchronous functions was not determined yet in Python. So by Python 3.6, the syntax of async is totally set in stone, and it's always, from now forever, asynchronous functions in Python will always be using this await and async syntax. And again, those are syntactic sugar over these sort of weird generators that are bidirectional. But since Python 3.6, and if you want to do this on your own computer, you could be using any version of Python that you want. 3.10, I believe, is the latest version. And there have been a number of improvements to asynchronous code since Python 3.6. And you would be welcome to use those if you wanted. But since we don't have those available on the Lambda server, not easily able to do them. But I will highlight one of them when we get to that, something that you could do on your own computer that you can't do on the Lambda server. But yeah, so the answer to the question is you can feel free to do this assignment on whatever computer you'd like. There's no need to access large data sets or anything on this assignment. As long as you have an internet connection, you can use your computer. Good question. Any other questions? Okay, so let's make this asynchronous. The first thing that we'll need to do, import Async Io. The Async Io library is the main library for doing asynchronous stuff. And so you always have to import it. And then change these definitions to async calls like this. Async like that. And let's go ahead and run this and see what's going to happen. There we go. And everything runs super fast. It runs instantly. We get a warning message right here, but we don't get any error messages. But our output right here, XS, it should be this list of numbers right here, but we're not actually getting this list of numbers. And to dive into that a little bit more deeply, I'm going to, so let's call Python interactively. The -i flag is going to load up this file and then give me a Python prompt that I can just work with directly. And we'll remind ourselves a little bit more about the details of these async functions right here. So again, if I type worker, just an ordinary function like this, hit enter, so no parentheses right here, then the value of this worker variable has type function. Say type of worker, it is a function. And when I call a function, I'm going to get some type of value returned. Normally, the value returned, oops, we have to pass something in because it takes a parameter right here. Just pass in a 0. Normally, let's take away this async for a second. We run this, do worker 0, and we can see that it returns the 0, actually runs hello, and it runs world for us, or prints those out. But if we make this function async, like that, and then rerun it, and now when I type worker 0, it doesn't actually run anything. Instead, what it returns is this coroutine object. So in Python terminology, async functions, so async def makes this a function. What it returns is a coroutine. Anytime you see the word coroutine anywhere in the output like this, it means that this was returned by an async function somewhere. And so in order to actually run a coroutine, that's where we need the event loop. So anytime you have one of these objects somehow and you want to run it, that's you need the event loop to do that. So we'll say loop equals async io dot new event loop like that, and then loop dot run until complete worker 0 like that. And there it actually goes through and runs this. Still getting this warning right here, which we'll talk about here in a second. But the important thing is that in order to actually run the async function, you have to use this event loop and this run until complete. if we were using Python 3.7 or greater, our benevolent dictator for life, all the Python High Council people realized that everybody was just running these two commands all the time immediately after each other. And so they introduced a function async io.run, which you could pass in worker 0 like this, and would automatically create the new event loop for you and then call run until complete. But this is not available in Python 3.6, so you can't do that. So you actually have to create the event loop and call run until complete like this. Okay, so this is actually, so it's calling hello, calling world, and then, yeah, that's great. But we have this runtime warning, coroutine worker was never awaited. Why, let's see. Yeah, what exactly is causing that? Anytime you have one of these async functions, you're supposed to await the async function. And so let's do this await syntax, see what happens when we do it inside of the Python interpreter. Await of worker of 0, something like this. You'll get an invalid syntax, or if we were to do inside of our run until complete, something like await worker 0 like this, you'll get an invalid syntax. This await keyword can only be used inside of another function, cannot be used outside of a function. And so if I did something like define a wrapper function like this, and then right here said await actually, let's skip that, not do that. The important thing at this point is just that await can't be called inside of a the Python interpreter. In order to see a little bit more about this this error message though, this warning about the worker not being awaited, which only happened the very first time. Loop equals. Oh. Seems that it has gone away. It happens when we close it. There we go. Happens when we close it. In order to see a little bit more about why we're getting this warning, we're going to move on to this main function. So now the main function down here, calling our worker function, worker I, like this, 10 different times, and putting the results in this list variable xs, call main, and print the results. Let's go ahead and run this. There we go. The XS down here, what's being printed right here, we're getting this coroutine. Anytime you're seeing something that's being printed as a coroutine, that's a sign that you are calling an async function directly, but you're not running the async function. So here we're calling the main async function, but we have no event loop. We're not running the main function, so we need to add an event loop. So let's do a loop equals async io.new event loop. And then down here, comment that out. Instead of just saying xx equals main, we'll say xs equals loop dot run until complete main, like that. The return value of run until complete is going to be the return value of whatever this function is right here after it's actually run. So this xs will be hopefully, eventually, a list containing all the numbers that are the outputs of the workers. Let's go ahead and save that, come up here and rerun it and see what happens. And now we are, in fact, getting a list of a whole bunch of stuff down here. So that's good, we're making progress. But this list is a list of a bunch of coroutine objects. Again, anytime you see a coroutine, it means that somehow we have some sort of async function that we are calling, but not actually running. And in this case, we have, so the worker is our asynchronous helper function that we're calling. We call it right here, but we're never actually running this asynchronous helper function. In order to run it, we need to use the await keyword. So when you're running a function directly from the from a synchronous function, when you're going from async back to synchronous, or when you're going from async to like normal Python, whether that normal Python is just like inside of a file like this or inside of the interpreter. Going from async to normal Python, you create the event loop, put things inside the event loop like this. When you are going from one async function to another async function though, in order to run that nested async function, you use the async keyword like this. Putting async in front of worker says actually run this worker. And if we do that and rerun it, oh, sorry, not async. Await. Async when you define it, so that it knows that it's something that is awaitable, await when you actually run it. And now we're getting back to the sequential code that we had before. And so even though we have asyncs up here and awaits in here and an event loop and doing all sorts of async looking stuff, things are still turning out to be sequential because our async code isn't quite written right. So at this point, this is essentially the state of what the wardial.py file is, what the current state of the task 2 is. And we need to keep going to fix this so that all of these things are going to run concurrently instead of sequentially. Any questions at this point about what's going on? Okay. So there's a couple of things that we should think about here about what's causing us to run sequentially. The first thing that jumps out to me, and this is something that's in a large project is really, really hard to find, is the fact that right here, I'm calling sequential code inside of asynchronous code. This is allowed, but it's guaranteed to make our code not asynchronous. And I'll say really asynchronous. It still has the async keyword and everything, but this code can't be synchronized with other code because of this call right here. This is a blocking call. This is not going to return our control of this program. It's not going to yield, call that yield keyword when it desugars to allow another function to run. And so I have to put, oops, instead of doing time.sleep1 like this, what I want to do is I want to call the async io.sleep. Async io.sleep. And now this is actually an asynchronous function that's being called. So now that we've made that change, let's go ahead up here, rerun that code. And we see that, wow, it's happening super, super fast. That seems amazing. But we should be suspicious because this is too fast, actually. If I time this, oops, and let's take out the interactive. If I time this, then everything happens in under a second. Yeah, it means this sleep call is not even nothing's actually happening with this sleep call. And again, whenever you're calling an asynchronous function, so this here is an asynchronous function, this generates a coroutine, but it doesn't actually run the coroutine. Anytime you're calling an asynchronous function, you need to put the async word in front of it in order to actually run it. So we changed it. What it used to be was just time.sleep1 like that. Changed it by changing it to the asynchronous function, which returns a coroutine, and then the async keyword in front of it says, let's actually run this coroutine. And now rerunning this, oops, if I get my, oops, again, async, not async, it's supposed to be await right here. You await an async function. And now it is actually waiting that 1 second here each time, but it is still fundamentally synchronous code. So the first bug we had, which isn't the only bug, but the first bug that we had was the calling sync code in async. Need to make sure that that gets fixed, but that's not enough by itself. The second bug that we have, and I'm going to sort of expand out this for loop here manually to make it a little bit more clear. This for loop is equivalent to saying await worker 0, and we'll just do 3 of these. I'll do 5 of them, like this. If we unroll this for loop, we get a bunch of await worker calls like this. And what's happening with these await worker calls, I guess actually we need to still have the XS equals that. And let's do XS dot append like that. So we're still appending into the list. What's happening here, anytime you say await worker, that this Python code is still sequential. This line is going to happen, and it must finish before this line happens and starts. And so even though we're using await right here, all that await does is mean that something else can happen while this code is going on, but this code still has to finish. This function still must finish before we can start on the next line down here. So the fact that these are happening one after the other is what's making our code still sequential here. In order to make this not still sequential, there is a built-in function called the gather function, which I think I mentioned last time, and we ran into an error with it last time. But here we'll get to see it, and it'll make things work. In Async Io .gather, this function takes as parameters coroutines. So again, a coroutine is the result of calling one of these functions without awaiting that function. Takes as parameters coroutines and sequentially or concurrently schedules them together into a single coroutine. The sort of the built-in stuff that's going behind the scenes in Gather is kind of like magic that's built into the Async Io library. So it's not something that we could easily implement by ourselves. But basically, anytime you want to have some sort of concurrency going on, you want to use the gather function. It will make whatever its arguments are able to run concurrently. All of its arguments will run concurrently. And so here I'll see XS of 0, XS of 1, XS of 2, XS of 3, XS of 4. So these are the 4 different, right here, 4 different entries in these, or I guess 5 different entries in this XS list created by these commands right here. And now let's go ahead and save that, come up here and run this. And things are still happening sequentially. So I said that gather is going to make things happen concurrently. Why are things still happening sequentially? And the answer is that, again, what gather does is it is an async function, and so it returns a coroutine. And we actually have to run that coroutine, tell it to run to the scheduler. And so we have to await that gather like this, await this gather. And I also mentioned that the input to gather is supposed to be coroutines. The output of an asynchronous function is a coroutine. This right here returns a coroutine. When you await a coroutine, it gives you back an actual value. So rather than putting the awaits in front of the workers up here, we put the await in front of the gather and then delete these awaits up here. Now when we run this, now we can see all those things happening concurrently. Still not fully done. We still have this weird list of XS's down here that still mention coroutines. So we'll fix that here in a second. But before we do that, I want to see some variants on different error messages that we can have. So what's going to happen if I await all of these workers and still await the gather like this? Run this. Now things are suddenly back to being sequential. We don't get an error message until the very end. We don't get an error message. It just makes everything happen sequentially. And again, if we take out that await down there, running everything, still everything happening sequentially, and still getting that error message. So it's key that whenever you call gather, the things that are being passed to gather are directly coroutines, directly the output of an async function, and not something that you've awaited, because awaiting it turns it into an actual value that can't be made asynchronous. So this is the, anytime you use gather, this is the sort of format that you want. The things being passed to gather are the direct outputs of the async function, the direct coroutines, and then you await the gather. Do that. I said our next problem to solve, though, is there's this excess list. This excess right here is being returned, and it's not giving us the actual like numbers that we want. It's just giving this weird list of coroutines. And again, excess contains the contents of one of these coroutines, and or it contains the coroutine itself and not the output of running the coroutine. And so when I just directly return excess, it's still equal to the coroutine, and so that's why it's saying coroutine up here. In this case, I happen to have run those coroutines because I called await on the gather right here. But running the coroutine doesn't directly replace the coroutine with the corresponding value. It just actually, it'll still say coroutine here. We saw before that anytime you have one of these coroutine objects, sort of the key idea, the key way to get rid of it is to run that somehow. Inside of an async function, the way to run that is to put an await in front of it. And so the first thought might be that we should put the await up here inside of these again, because that's going to actually run these coroutine objects right here and put the values inside of this excess list. But again, if we do that, things are not going to happen sequentially, or they will happen sequentially, not happen concurrently. And so the result of the gather down here is going to be the actual results of running these things. And so down here, if I said excess equals that, so this excess right here is now a new excess that is the result of running these previous ones. Now it's going to actually substitute in the values of running those coroutines here and get these numbers. A lot of very subtle things going on with these await calls and the gather and getting them like ordered just right. And again, like the error messages, very weird, unintuitive, and so it can be difficult to figure out if you haven't seen them before. But in your wardial code, you'll need to make sure that you're calling gather. The things that are being passed to gather are coroutines, not awaited coroutines, and then you await the final result of gather like this. Any questions about any of that so far? Does that feel like it was all making sense, or a lot of stuff going on that takes playing around before it makes sense? I think that's the right way to be feeling right now, is that like this is not something that you can really get a feel for with just seeing it explained. It'll just take some playing around with it. Yeah. One last thing, weird thing about this gather function, which makes no sense to me about why they chose to implement it this way. But the gather function cannot take as an argument a list of things that you want to run concurrently. for whatever reason, you have to pass in each one of the things as its own separate value like this. And so in this case, I have 5 of these. I know there's going to be exactly 5 of these values, and so I can just hard code the values like this, and that works. But what about in the situation like I had up here, where there's some for loop, and okay, in this case, I happen to hard code the number 10, but maybe this is like a user supplied value, or maybe this number is like 1,000,000, and so I don't want to like pass in 1,000,000 things manually to a function. How do you do that? And let's see, I'm going to just comment all of this for a second so we don't lose it, but it's not going to run. And there's a syntax in Python. We say so return await async io.gather, and then XS like this. This will not run. We'll see what's going to happen. I'll run that, and everything here is going sequentially. I think we'll get an error message here when it finishes. Yeah, this unhashable type list. If we change this to have, oh yeah, so it's happening sequentially because of this. We put the awaits right here. We need to delete that await. So rerun that. There we go. Now it just immediately gets us to this error message, unhashable type list like this. And what we need to do is you put a star in front of a list. And when you put a star in front of a list in Python, there's just this special syntax that only works inside of a function call. This says decompose the list so that each one of these entries are individual parameters to this function right here. And so that's the thing that you actually want to do, and then it will call those. And so in your wardial, you'll have 1,000, 10,000, however many IP addresses that it's scanning over. And by putting the star in front of the list of IP addresses, it'll pass those to gather nicely. Any questions about that?
Professor, I think I have a question. I'm still like not understanding. What about the number 10? How can we like replace that if we don't know how many number are we returning?
So yeah, so here this number 10 is, let's see, we can, if this is just like an in, and then passing in and in to the main function, and then down here inside of the main function, we'll put 20 this time, and call that, and now it happens 20 times. So it's true that like I'm basically hard coding this value still, but the idea is just that this star syntax works no matter, like it doesn't have to know how many things are in this list for it to work. You can just call it like that.
Thank you.
Let's see, one other thing to talk about. So here, there were 2 bugs that we had to fix. The first bug up here was there was some operations that were not asynchronous that should have been asynchronous, something like that. And then our second bug down here, not using the gather, but just having the for loop. And so what would happen if we fixed the second bug down here before fixing the bug up here? Then now let's call this and see what happens. So all I've done up here is change this so that it's calling actual time.sleep and not the asynchronous one. Run that, and we'll see that it happens to be running all of those things asynchronously still. What happens if we call Async Io without the await? That's the one that I wanted to get. We see that things happen instantly. It's not actually doing any of these operations down here. It's not actually doing any of these sleep operations, any of these IO operations. That you have to make sure that anytime you're calling a async function, again, this is only going to return the coroutine. You have to await the coroutine in order to run it. And so there we go, something like that. We'll actually run it doing the wait right there. yeah, so again, those thought processes, what you'll have to work through on the async function right here. You have this for loop, you have to convert it into the appropriate gather call, making sure that everything is using the async versions of functions and awaiting at the appropriate moments. And if you do that, then your whole code will run very fast. That's everything for us to cover about async functions. And again, maybe one last thing about how this ties into the rest of the course, that this is, here the example, not for simplicity, we're not interacting with the database at all. We're just doing web requests. But the latest version, like bleeding edge months ago released of that Psycho PG Python driver is async, so that you can access the database asynchronously now, run multiple SQL queries asynchronously in Python, and these same techniques are how you do that. Any other questions about anything at all? Okay, then that's everything for the course. I enjoyed having you all in the course. I know it's kind of weird scheduling wise with extra class per week and the baby and things. But I appreciate you all bearing with me with all of that, and it was great having you all, and hope to see you all again in future classes. If there's anything I can do for any of you at any point in the future, whether it's career-wise, academic-wise, anything at all, please don't hesitate to ask, and I would love to help out. But yeah, that is the end of big data. I feel like it's I don't know, anticlimactic ending with all of the finals being weird scheduled and things, but